We've learned a bit about structured data and how structured data can be used and analyzed and understood. But we're going to have to extract it and we're going to have to manipulate it. And fortunately, that's a common enough thing that there's an entire language developed around doing this, and that language is called structured query language. So structured query language, we usually hear it called SQL. Most people pronounce SQL as SQL. Some people say SQL, but that's only just a few syllables less than structured query language, so SQL really works for me. Maybe it works for you too. SQL is not a general purpose programming language. You're not going to be able to go out and write entire applications in this. Now, Oracle did try to create PL SQL, which is, I believe, procedural language SQL, to do a lot more with SQL, but I don't know that that kind of approach has really ever caught on. So I would kind of focus on SQL as something that does one particular thing, and that one particular thing is extracting data, manipulating data, sometimes transforming data. SQL is a purpose-focused language. It's used for creating, retrieving, updating, deleting data from relational databases primarily. It's not the only purpose for it. You'll find that other applications sometimes do use SQL as well. Now, if you look at these creating, retrieving, updating, and deleting, we often say CRUD, C-R-U-D. Those are the 4 letters in CRUD: create, retrieve, update, delete. And often that just means that sometimes we're going to be creating data or modifying data. So that's your create and your update. And typically we'll be retrieving data, and sometimes you'll even be deleting data. Though, to be completely honest, most people don't delete much data in 2023. It's actually much better to just kind of hide it or make it not visible to users, because why throw away data? That's just crazy. Unless you're obligated to do so for certain purposes, it just seems like most of the time you want to just keep the data around. So select statements are the most common type of statement you'll see in SQL, especially for the purposes of data extraction. You typically won't see an insert statement, an update, a delete, or a create statement, especially when you're working with data warehouses. Data warehouses are usually built in a way that you don't want to be making updates or insertions other than just completely redoing the entire data warehouse. So often we're going to be working with select statements in data warehouses. So we're going to cover those, and we're going to kind of look at how you can do this. This is going to be like the fastest crash course in SQL that you ever see, though I can recommend a book. I'll put a link to it in the comments. There's a great book called Teach Yourself SQL in 10 Minutes. It's actually my very favorite database book ever. I find it to be very short to the point and allows you to learn a lot of things quickly. I actually had an interview where I needed to know SQL many, many years ago, and I picked that book up. I read it in a weekend, and that's kind of how I learned SQL and how I really got to understand all of these things in databases. So we'll start with select statements. In fact, we'll primarily cover select statements. Select statements usually follow this particular pattern. Select some number of columns. Sometimes you see select star from some particular table. Often that is one table. Sometimes it's multiple tables joined together, which we'll cover in just a moment. Where we'll have conditions to limit or filter our data, and then order by, where we will try to organize our data. Now, depending on what tool you're using, maybe order by isn't even altogether that valuable. Some tools will allow you to execute a query and then do sorting by column based on the output there. But if we're working through command line interfaces or anything like that, we'll probably have to use an order by so that we can start off with that order a little bit more directly. So probably the most simple SQL query you'll see, and where a lot of people will start. In fact, I've been a member of groups that call them select star, because select star is such a common way to kind of get into a table. If you start with this, select star from some table, this is fine in a typical database, except that in a data warehouse, what you're going to run into is that this may be gigabytes, maybe even more of data, which if you try to run a SQL query that is too large, a lot of times your engine will just not work, or it will run strangely, or it will be very slow. There's a certain threshold for most data warehouses where a query of a certain size suddenly becomes very complicated, very difficult to execute. So select star from some table is probably not a great way to go when working with data warehouses. Select star from a table where you limit, this is good, this is actually much better, but what you might run into in a lot of data warehousing situations, you may have a few dozen columns, you may have hundreds of columns. I've seen data warehouses that have over 1,000 columns. So how do you make sense of that? How do you really work with thousands of columns? That's very difficult to do. So select star from some table where you have a limit. It's better, but maybe not giving you exactly what you need. Now this is going to work a lot better, and if you do this, what you're going to run into is that this actually limits your data so that you can get a kind of good look at it for the first time. Select a couple of columns, the columns you're most interested in investigating or analyzing from a particular table. table, and then you have a limit. So, ideally, if these are simple or straightforward columns with straightforward data types, you're going to end up with maybe 4 long strings, or maybe, a long string and some integers or some floating point numbers. Something that's a little bit easier, a little bit more digestible. In fact, something like this, you could throw it into a spreadsheet. You could just extract it. But, with 4 columns and 100 lines, you could probably just copy and paste that into a spreadsheet. So that will help you to investigate your data. But the problem is that limit 100, sometimes a data warehouse is going to have a few hundred, maybe even a few thousand records of just junk data, or just data that's empty, or something that's not very useful. So this may not be the best way to start, but once you've had this impression of your data, you might be able to go a little bit further, where you're starting to apply these where clauses. So this might be a lot of data, or it might not be the right data, but it's giving us a little bit more of an understanding of that data. Like a common thing you might do is, if there's a particular one of these, column 1, column 2, column 5, whatever that you're concerned with, you might want to select, the columns from your table where this thing is not null, or this thing is not empty. And that way you get a little bit more understanding of what the real data is, because the data warehouse often isn't well cleaned or well-maintained data. It may just be data that's dumped. I mean, a data warehouse is literally, it's like a warehouse. Sometimes there are shelves that have stuff on and nobody really understands what that is. So a warehouse is a really good metaphor for a data warehouse, because it's going to be a large building that has many things in it, and many of those will be valuable, but some of them will be obscure. I think that it's the end of Indiana Jones where you see them going into this giant warehouse and they're storing stuff, and it's like just huge. It's just cavernous, and so who's to say how all of that was organized or where to find things? So going even a step farther, you can start to combine your where clauses so that we can start seeing more details on this data. So even if we're limiting our data, we can kind of get the right data to start our conversation or start our analysis. And this is going to be really useful when we start looking at what we might need for training some of our models, or performing some regression or forecasting techniques. So we can use logical operators in our where clauses like and, or, not. And you can also use a lot of comparison operators like equals, not equals, less than, greater than, less than or equal to, greater than or equal to. So kind of the common programming logical Boolean operators. And then you also have a like for most languages. You have in, you have between. Now, the thing about SQL that's a little bit strange, and this is important to call out, is that not every SQL dialect is the same. You might have a particular version of SQL for Oracle. You might have a particular version of SQL for SQL Server, and they may not have exactly the same syntax or even exactly the same features. But typically you're going to see these things. Typically everything is going to follow a select, from, where, order by kind of approach, and then also have and, or, not, and these operators. Like in between may have varying levels of support, but we'll kind of look at these as we actually get into some examples. So when you work with like, you often have wildcards. In BigQuery, we're going to take a look at this. %sign is your wildcard. That can vary from dialect to dialect. We also can look at in, so you can kind of say, like, we're going to look at data where this particular column or this particular field of data is in one of these values. It's one of these particular options. So that prevents you from having to say where column 1 is equal to 1, or column 1 is equal to 5, or column 1 is equal to 9. So you can kind of use this in to shortcut that operation. And then you also have between queries, so you can kind of check ranges. You can see anywhere where it's in this particular range. And as you dig into understanding your data, this is going to help you to understand to define some rules for yourself, or define some heuristics, so that you can start to understand, because before the machine can understand, sometimes you have to do a little bit of work on your own to understand the problem and understand the dimensions and understand the attributes of the data that you're working with. This can really help as you're starting to set up and engineer the data that you're going to use for training your models. So the last thing, this is probably more important for when you're just looking at the data, because your models probably won't care too much about the ordering of the data necessarily. So we can order by, and we can order by individual columns, and we can order ascending or descending order. So you can say we're going to select a bunch of these things and we're going to order by this column. We're going to order by this column descending. But like I said, depending on the tools you're using, you might have that capability right in your user interface. You can also join tables together. You can take table A, for example, if we go back to I think the previous presentation, we had classes and we had table matching classes to instructors. So we would we would put those all together using a join. And we typically have two kinds of joins. We have an inner join where we're going to say, we're going to take column A, and every field in table 1 that matches, the column matches this column in table 2. So we're going to say an inner join, like everything has to match up. We have to have this sort of match on table 1 and table 2. Sometimes in the query we'll call that the left table or the right table. Actually, not sometimes. Typically, only when we're dealing with joins, we'll call these left table and right table. But an outer join is going to take all of the records from one table, whether or not they match, and then only matching records on another table. So you sometimes hear left join or right join. Left outer join, right outer join. Basically, it's whether or not we're taking the unrelated records from the left table or the right table. Fortunately, you don't have to worry about joins too much. Joins are kind of a complicated thing that not everybody gets intuitively. It doesn't necessarily come fast, but the point of the data warehouse is that it's got all of this work done for you already. You won't have to perform as many joins in a data warehouse because typically they're very denormalized, and you won't have to go through the process of figuring out where I do an outer join, where I do an inner join. Now, we might have to do one or two here or there, but most of the time that work is sort of done further up in the data manipulation pipeline. We also have SQL functions, and these can be extremely useful when you are trying to understand data. So you can use SQL functions to aggregate data, both for average, max, min, sum, and count. Count is really common, like if we want to count particular things, and we can group by using SQL queries, and we'll see that in just in future presentations, where we select maybe a count of things and then we group by, so we can kind of see what the groupings are there. And that can be useful for just understanding how much data we have that fits particular criteria. There are also typically SQL functions in different dialects, different applications for date manipulation, manipulating strings, extracting information from objects, doing different things with lists. It just depends on how complicated the database is and how complicated that SQL language is, what kind of features you have. And it's not always obvious right away, so sometimes you have to try some things, or sometimes you just have to be well-versed in using SQL for a particular purpose. But we'll explore all of this as we move through the rest of the course. That's all we're going to cover on SQL for now. Now, SQL is a very long topic. You can probably take 4, 5, 6 months studying just SQL and still kind of learning things about that. In fact, you can easily take 4, 5, 6 months and study databases and learn a lot about how databases operate and the theory and the practice and how all of that works. We're just going to cover enough so that we can actually get in and start extracting the data we need. So hopefully this is a good start, and hopefully this will give you the basis to really build on this as we look into some of the data that we're going to explore. Thank you for watching.